All right, let's solve some systems of equations with elimination. Now, these are the three problems that I gave you yesterday in class. Let's see how we work these. Okay, so looking at these first two equations here, what I'm looking at when I look at these equations is I'm looking at which two could I most easily get rid of. Well, right here, that is a negative 4x, and this one is a positive 2. Well, using the old multiplication, I know that I can multiply 2 times 2 and get 4. And it would be a positive 4x and a negative 4x. So that would be easy to wipe those out, which is what I'm looking for. I'm looking to eliminate a variable. So that's what I'm going to do. I'm going to take this top equation here, and I'm going to multiply that entire top equation times 2 because I want it to be the opposite of what the bottom equation is. So when I do that, it is now going to be 4x plus 2y is equal to 12. A lot of people forget that you have to distribute. You have to multiply that 2 times that 6 out there also. So don't forget about that. Now, when I line up my two equations, minus 2y, and this is a positive 5, I've now lined up my two equations, and I'm going to add them. So 12 plus 5 is just plain 17. The positive 2y and the negative 2y will be eliminated, and so will the 4x and the negative 4x, which is the ones I had planned to eliminate. I didn't plan to eliminate the y's there. So that winds up with nothing. Okay, so here I've got 0 is equal to 17. Well, I can tell you right away that that is not true. So if you think back to some of the equations we have done in the past, when you get something that is not true, that will tell you something about our solution, or what kind of solution we have here. Okay, moving to the next two that we have. Just looking at these, there's a couple of different things I could do. See, right here I've got a negative x and a positive x, and it would be easy enough to multiply that one by 2. I could also look and see here I've got a positive 5y and a negative 10y. So that would be easy enough. So what I'm going to do is I'm going to take the top equation and I'm just going to multiply it times 2. Don't need to multiply it times a negative 2 because it's already got a negative x there. 5y is equal to negative 6. So now when I multiply this, I'm going to get a negative 2x plus 10y is equal to negative 12. Again, remembering to multiply out there. Now when I line up my other equation, okay, you might be able to see that I'm going to get a little something interesting is going to happen here. So I'm adding these together. Positive 12, negative 12, that's nothing. These two will cancel, and these two will cancel. Wow. So I'm left with nothing there. But in this case, this is a true statement. So this, if you think back to some of the other systems of equations that we have worked, this should tell you about what kind of answer we're going to have here. This is a true statement. All right. Our final two problems, final two equations. All right, so I'm looking at this one, and I'm seeing right here I've got these x's are both positive, so I'm probably not going to do anything there. I don't like to multiply by negative numbers because if I miss a sign change, I miss the entire problem. This is looking pretty good here. So I like this in the y's there. So if I multiply this top equation times 2, it should give me the change that I'm looking for. I should get a positive 2y. And then I've got a negative 2y on my second equation there. So this would be 6x plus 2y is equal to 4. Getting my other equation and lining it up to do the business here and add. Minus 2y is equal to 10. Now this is where you've got to keep in mind what you're doing. I am adding these two equations. So 10 plus 4 is 14. Positive and negative, those cancel out like I had planned it, that's good. Over here, now I would add these and get 7x. So now it's just an algebra problem. So 7x is equal to 14. I need to get rid of the coefficient there in front. So this is going to be x is equal to 2. Well, now I can take this, since I know x is equal to 2, I can take either equation. Doesn't matter which equation I take. I'm going to take the first one just because I see it right there. And I can substitute in the value for x. So this is 6 is plus y is equal to 2. Well, now then I have to take away the 6. And I get y is equal to negative 4. So I get an answer here of 2 and negative 4. So we get 2 and negative 4 would be my coordinates. Let's see if I substitute them in, see if it works. Let me see. Tell you what, let's do this. I'll substitute it in for this top one up here. Actually, let me make some room. Do some erasing right here. You wouldn't want to do this on your own paper. I'm just doing it because I have an electronic screen and I can do it easily. All right. So 3 times 2 plus a negative 4 is equal to 2. So there'd be 6, basically minus 4, plus a negative is basically minus, is equal to 2. And that is true. 2 is equal to 2. That's a good thing. Now, if I check out my other one, and it works out also, then it's awesome. So 2 minus 2 times a negative 4, I did that probably the worst way you could possibly do it, is equal to 10. So negative 2 times a negative 4 is going to be a negative times a negative is a positive. So that would be positive 8, and that is 10. And that is 10 is equal to 10. So these both check out. So that tells me this is the correct answer. Okay, this is what you should have gotten as you worked through the 3 problems that I gave you. If you got the right answers, then I think you're ready to work on an assignment. If not, then you might want to do a little practice with me here in just a moment. Good luck.